Hi, welcome everyone. So, I am Ege, and I will be talking about the Eclipse Thingweb project and how its next chapter is starting and how we are scaling it up for different and better IoT and digital twin applications. Yeah, so that's me. I'm from Siemens. I work on the R&D, and soon some others will join me remotely. So Cristiano from Italy and also Jan from Germany will have their appearance. Yeah, and I'll start with an ideal image of an IoT project and how we think things would happen. Well, at least 15 years ago. So we would have thought that, okay, there is a protocol we use or a framework, and then I just use it everywhere in my devices, my end applications, and then it just works, and I can make my business with it. And actually, it doesn't really work like this. So if we look into the reality, it's quite different. We have multitude of protocols. In open source projects, there are also device-specific drivers, complex integrations with cloud solutions and so on, and you have 20-year-old devices. And all of this is happening over a long period of time where you have changing requirements at the same time. And some time ago, we decided to tackle this from two fronts. On one side, open standards. On the other side, open source software. Yeah, and the Thingweb name actually comes from this. So if you look at it, it's actually just composed of two words, thing and web thing, and web of things. And now your question might be, but what is the web of things? And web of things is simply a set of standards by the W3C, so the organization that does the browser standards. It is royalty-free and open. And you can even look at the last meeting minutes, including everything. It's very important to be developer-friendly, where every single feature is implemented in two different code bases at least. It has market adoption and also open source adoption, meaning it's also used in various open source projects within Eclipse or outside. And in the end, it's actually just about having an API description for everything. That means for things that are from different protocols, different frameworks, different data structures, different serialization formats, and even more. And in the end, it's really not a protocol, so it's not something specific, like a protocol stack that you have to implement, but it's actually about bridging the network protocols to the affordances, or to the capabilities of the device, when we add some semantics on top of it so that we can now have applications that can really use these devices. And this is all happening thanks to the thing description standard, which is basically creating a narrow waist model, meaning on the bottom we have devices from different manufacturers, different protocols, and so on. And with adding a tiny bit of abstraction, we can start building apps that can just scale towards multiple domains and multiple protocols. That's what you're seeing. Probably not the best from the back, but basically you can have a thing description which is a JSON format, and you can see an HTTP device on one side and a Modbus device on the other. So in the end, it's when you see and look at the details here, so to say, you can see that the concrete protocols are being referenced. So what do you do with a TD? So first of all, you can start communicating with the thing. So you can parse it and then start generating the concrete requests. You can proxy it, so this Modbus protocol you've seen in the TD becomes another protocol through your gateway. You can generate UI, so it's easy to interact with it. And you can do device management, since now you have more metadata about your device. And then later on, you can think of, okay, what do I really want to do with this device? So is it a temperature control scenario? Do I need to do a conveyor belt or control, or what I need to do? And in the end, we think that these are the foundational blocks for building digital twins. In the end, a digital twin needs to have the real data from the device, and we'll come to it. And as I said, it has adoption, and we have been working hard to make sure that this is visible. So we have been hosting meetups where this is shown through different domains, like industrial automation, building automation, or hobbyist projects. And we also have another one on Monday, so if you're interested, just reach out to me. And also at the same time, we are seeing adoption from different organizations who are basically changing their device models. So in this case, for example, the Microsoft's digital twin definition language is migrating to the TD in its third release version. Yeah, and we did all this work, and people wrote all the standards. So in the end, these are the experts, right? So that means developers don't need to think too much. They don't have much work to do. And of course, that's not the case. It's the opposite. We now have more work to do, in a way. And that's actually what brings us to the open source software. So in the end, since the beginning of the standardization efforts, we wanted to make sure that everything is implementable and accessible to the open source community. And that's where the Eclipse Thingweb's mission comes in. Thingweb has two goals in its mission. On one hand, it's helping the web developers who are very happy with HTML, JavaScript, and so on. But then once they look a bit down to these devices, you see some weird protocols, and they really don't like it. So they don't want to deal with these bits and bytes or writing to coils or, I don't know, understanding a completely new world. And on the other side, we want to help the IoT developers who are more familiar with these kind of protocols to bridge their devices or their applications to the web scale. And for this, they are not happy with what is out there with all the HTML, JavaScript, so they also need a bit of support, because in the end, in these days, every application tends to run in the web some way. So they also need some support. And that's how the Thingweb came to be, basically providing the reference implementations for the standards and making sure that people have this easy life of developing these IoT applications. And actually, we were quite successful in the beginning. And then we started getting, do you support Modbus? Do you support OPC UA? Well, can you support my company's IoT platform? And then these requests pile up. And then what you say, of course, as any open source project, well, OK, just make an pull request, and we'll gladly accept it. And actually, in many cases, these pull requests really come through. And we start piling up and getting more and more folders in our repositories, or simply more code that we need to think of and maintain, which is actually coming on top of us when we think of the future of the project. And in the end, a lot of things have happened over the last 2 years or so, where we really sat down and thought how we can really address all of these people's demands and all of these different additions that people want. And we have done quite a lot in the last 2 years, whether it be integration into different platforms like Node-RED, different standardization formats like asset administration shell, which will be talked in the next session, or simply more talking with the users. And with it, we also have a brand new website. Oh, OK, the browser doesn't work. OK, that's good to know. I am kind of ready. But anyways, so we also have a brand new website that is at thingweb.io that we have built and released a week ago to make sure that all of these changes are reflected and can be communicated easily to the audience. And with all of this work, we have understood how people, well, the developers, use Web of Things and how Thingweb can help them. So it was a really people-driven process where we sat down and talked with the people. And we started identifying different kinds of workflows that people are using. So these are from the new website. So some of the workflows we identify is first a more simplified one where people just wanted to interact with the devices. So we call this the client only. So you just take one library and you have an off-the-shelf device and you can just use it. The other one is where people want a more like an SDK kind of experience. So you want to have the devices and the clients talking to the Thingweb components, so that you can build everything in a much easier way. This is, of course, in the trade-off of you have more decisions taking for you. So you can get started also actually easily. And the last one, what we call is the platform. So people actually wanted to take some components and build a platform where they need to manage maybe thousands of devices. And for that, we started working on building these kind of components, such as device description management, so the metadata repositories. Yeah, and with this, I forgot to bring my device, so I will have a short demo. Sorry, I wasn't supposed to leave the presenter screen. Right, so I'll do a short demo. So this time, I will be representing the device manufacturer, so from Siemens side. There will be a gateway or edge developer, and somebody who wants to build the end application that we want to really give to the end consumers. Of course, in this case, you have the device. Then something needs to run in a gateway or an edge device where this protocol transition sort of happens. And of course, you need the, let's say, the smartphone where this is running. And in all of this, the data and all of this metadata needs to flow perfectly. Yeah, and as a specific case, I have brought this energy meter. This is not a marketing slide for Siemens. It's just that it's a very typical device. And with it, basically, you can monitor the energy consumption in your home. You can measure multiple phases, and yeah. And this happens to use the Modbus protocol from 20, 30 years ago. And if we were, yeah, if I wasn't here, probably you would have gotten a PDF with this document, with this device. Basically, still it's sometimes the case that when you give this device to the developer, you give a 150-page PDF, and you tell them, oh, please go to page 135, appendix 8.2, and there is a table with 300 rows, and you should go and find exactly what you need to talk with the device. I could imagine that this is not the best for the developers, but at the same time, it's not enough when we think of the European regulation on the digital product passport. The EU is requiring in a couple of years that every device, including these, come with a machine-readable digital passport of the device so that it can be used for multiple use cases. And a part of the digital product passport is the thing description. Other parts like, I don't know, the CO2 footprint or electrical instructions and so on, they are not concerned. But with this, I actually want to give a thing description to Cristiano, so to the gateway developer. And for this, I went through and wrote a thing description. This is actually coming from the product development process, so I don't have to go and sit down since this data is managed by the company anyways. And then I can go and click share, and I can give a link of this thing description to Cristiano. And with this, he should be ready, and I can send my device for the development to Cristiano.
Huh. It seems like Hagen is a hand to proxy the voltage information from a Siemens device to Ian, so you can display the values on a mobile app. Okay. IoTX. Nice project. Let's get this started. So Ege already attached the theme description, TD, which is awesome. But wait, I think I need a device. Oh, perfect timing. Coming! Thank you. So, what do we have here? We have a nice Siemens Center Pack 4200. Let's get this installed. Okay, we should have everything that we need. So, to kick off the development, we are going to use What Application Manager, or WAM. First, let's scaffold the project by running one init demo. This will set up the project and install the necessary dependency. We're using JavaScript for today, and we leave everything else as a default. I have already initialized the project ahead of time, so we are just going to use that one. Okay, WAM has scaffolded a simple NPM project with initial script called Thing.js. Now our first task is to import the Siemens Center TD into the project. But before we proceed, let's see quickly the TD shared by Hege. The links point to Thingweb playground, where we can validate it and see its properties. Okay, we have just a few warnings, nothing critical for today. We can move forward. I'm going to create a source.td.json file to store the TD. Notice that I'm using the td.json extension so that TD code can recognize it correctly. TD code provides the same functionalities as the playground, but right inside your IDE, which is super convenient, right? So now that we have a TD, we can import it into our script and create a runtime object to interact with the device. We'll use the consume function and print the device title just to verify that everything is working. WAM will handle the building and running your application for us. Okay, Great, everything is working so far. Next, let's read the voltage level. This again is pretty straightforward. We just need to simply call the read property function with the property name that we want. We get back a response object, much like the fetch API. From there, we use the value function to parse the data and validate it against its schema. Let's run the application once again, and perfect. It's reading the voltage as expected. Now we need to poll the data continuously so we can create a real-time graph for Jan's application. In JavaScript, we can easily use the setInterval function to do this. So once again, we run the application and see if everything is working. Okay, great. Everything is running smoothly. All right, we are in the final phase. So finally, we need to publish these recorded values to an MQTT broker. We could have done this using the MQTT SDK, but since we are following the what paradigm, we create a thing description with the MQTT protocol binding and share that with Jan. This way we can easily read the values without much extra effort. So let's create a target TD. Notice how TD code provides snippets to quickly scaffold the TD, include this tab for properties. So here is what the final TD looks like. We have defined the voltage property with all the required schema information, and now to retrieve that from the network. So now let's make the function asynchronous and write the voltage property to the MQTT broker. Pretty easy. One last run. Okay, perfect. Everything is working as expected. So for the final step, we'll publish the TD to a thing description directory so Jan can discover it easily. I could automate this, but for the sake of this demo, let me show how to manually post the TD via the TDD Swagger interface. All right, so I go over there and I can just copy it over and click send post. We get back an ID and I can use that ID to build a link and share that with Jan. Jan, everything is ready. It's over you now.
Thank you, Cristiano, and hi OCX. I have a similar use case, but I want to create a cross-platform app for Android and macOS. Luckily, Eclipse Thingweb also features the library .what, which I can use to build an app with the Flutter framework. I can use the MQTT thing description from Chris, and it should be good enough to get started. In my Flutter project, I've created 3 screens. One for setting discovery options, one for listing the TDs that have been discovered, and one for displaying the data retrieved from a thing. From the command line, I can use Flutter run to start the application in debug mode and run it on an emulated Android device, which you can see on the right. After pasting the URL from Chris in the settings, I can retrieve the TD via .what on the main screen and click on the TD title to open the screen for the thing. Here I can now start the process for retrieving the values of the energy meter, also using .what, and display them in a neat graph. Due to the cross-platform nature of Flutter, I can also create an app for macOS from the same codebase and also start it with Flutter Run. The same also works for Linux, Windows and iOS, so Thingweb enables you to develop apps with what support for all of these platforms. Back to you, Ege.
Right. So actually what you have seen was different people working together and different interoperable components working together. As you've seen, we didn't run a Docker Compose file which started all of these things. They are just coordinating thanks to the thing descriptions and to the open source components that we provide. And these components, as you've seen, they are just meant that you can just pick what you need and use them as you see fit. So you don't need to take the whole thing or the whole stack of the different components. And these components, in the order of appearance, so to say, they were first a TD Playground, where we could basically validate or see the thing description. Then the VAM CLI has scaffolded the project so that Cristiano can use Node.what to start interacting with the device using the protocols. Then he was supported by the TD Code, which is a VS Code extension that we provide, and could then share the thing description on a thing description directory with Jan. Jan has been using the .what to create a Flutter application. And in the meantime, our toolings, they were supporting them with different utility libraries and so on and so forth. At the same time, after talking with people, we have realized that some people also need things to just get started right away. So they didn't want just the code, but actually they wanted something that is just ready to use. And with this, thanks to the Eclipse Foundation, actually, we could start hosting different services for free for us. And as you've seen, the Thingweb Playground is one such service. Our thing description directory is another one. And also the public things, which are now available on the public internet. If you want to test our thing description or our stacks, you can just use them anytime right now. And these are all possible. Either it's hosted in the Eclipse, or since we are an open source project, we can very easily get free accounts from different providers like Netlify, Docker Hub, and so on and so forth. Since, if we were not open source, we would have to pay a lot of money in the end. So this is a very good benefit of the foundation for us. And basically, recognizing how the developers want to use our components was the key for more adoption. So going and talking to the people who are most developers, and they just want to code and so on, it was actually the real important thing so that we can really get the concrete feedback. And this has brought us to the adopters, where we are also now using the Eclipse IoT's adopters program so that companies can put their logos in fully legal framework so that we don't have any issues with their logo usage. But very specifically, this is called the adopters, and this is going through a specific process. But this is actually just the tip of the iceberg. And if you look at the users in general across different industries, of course, the adopters are some, but also different companies are also using it in their commercial offerings. Also, other organizations who use it in their standardization process or through proof of concepts when they do demo applications and so on. Also, universities who use it in their research or research labs, or also other projects who use it within their research endeavors. And yeah, actually, I am more or less done. So if you want to learn more about the Web of Things and the Thingweb, you can look at the official W3C page, w3org/what, or Thingweb.io. And if you are really interested to learn and see what it really is with your own hands, you can join us in Munich in the last week of November. And you can basically hack those devices together to build scenarios that make sense to really show that they are interoperable between themselves. We have basically 2 days, 3 days happening in CMAS and 2 at Microsoft, where we will have the Plug Fest, so this hackathon kind of thing, then some keynotes and standardization discussions. So if you're interested, just reach out to me. I'll be happy to share the logistics. Yeah, so I am still around here, so if you want to talk about any of these topics, I'll be very happy to do so. And yeah, here are the QR codes that you may need when you want to look into different things I've shown. Thank you. Yeah, I'm open for questions. Okay. Ah, okay.
Yes, thank you very much for your very interesting presentation. I know we are aware of your project, but in your slides you were mentioning that you also contribute, or your project also contribute with content to the digital product passport. Could you please elaborate on how far this is, it's working, or what are the activities going on? Because there are a lot of other activities related to that. I'd be interested to understand how you see the contributions of projects contributing to the overall concept of the digital product passports.
Yeah.
Thank you.
So actually one of the components that we have, so the playground, it actually has a component inside which allows the thing description to be converted to an asset administration shell submodel, and this can be just basically part of the digital product passport of the product, which includes other information like I don't know, all of the mounting and electrical connections and CO2 footprint. So concretely, this is what we're doing, but actually also an AAS application can basically get the submodel and use our libraries in different languages to start interacting with the device. So that's the concrete contribution we're doing. Okay, I guess that's it. Thank you.